We're still good. All right. Let's come back up to the front here. We started talking about exponential functions. Remember your quiz, well, half your quiz was on graphing exponential functions, right? So like what are exponential functions? Well, we've worked with exponents before and you've seen functions with exponents like x squared, x to the seventh, stuff like that. But those actually aren't exponential functions. To be an exponential function, x has to be in the power, okay? So you have to raise it to the x or something involving x power. And that's what an exponential is. It has a weird graph that looks like this depending on if you have a fraction or something greater than 1. So we learned all about graphing it. And then we started talking about this number called e, which, is basically kind of like, it's kind of like a shorthand for a number, kind of like how pi is. So it's not like a crazy variable or anything. Whenever you see e, all it stands for is like 2.718 with a bunch of other numbers past it. So, I mean, it's a useful number. Mathematicians use it a lot. I told you I wasn't going to explain how it like was created, but if you want to talk to me about that, we can. And the fun thing about e is, well, it defines this function called the natural exponential function, which is just e to the x. Okay, so it's just a special number that gets used a lot, and that's why it's kind of important. Okay, now we graphed e, and then I told you that e plays a part, and actually exponential functions in general, they come about a lot in a lot of applications. In particular, for this class, business applications. Now, I'll tell you that I never taught this like business class before. I taught algebra before, but it was like more for the science majors. I don't really know much about interest, and I learned about it over the weekend. So now I'm going to tell you what I learned in the past like 5 days. This is my understanding of what interest is. Hmm? Oh. There we go. That's better. All right. So there's 2 types of interest. Interest, well, okay, before we start getting into that, let's talk about like when interest is useful, okay? Interest will be useful to you if for any reason you need to take out a loan, right? So a lot of you have like student loans, or if you buy a house in the future, you're gonna have to take a loan for that unless you have the money up front, right? Another use of interest is when you're investing money. So you put a bunch of money into the bank or some sort of investment company. And basically, just by having your money sit there, you gain money called interest, right? So let's just say I'm investing money and I want to invest $850. So I don't really want to use it right now. I just want to have it sit in the bank and kind of accrue interest, okay? I didn't really think about that, but yes, I guess I don't need the dollar sign there. Yeah, or the word dollars. Yeah. No, you're good. That is kind of funny. All right. Whatever you put in to the bank, we're gonna call that the principal. Actually, pretty much any money that's like sitting in your bank as it accumulates interest, the money that belongs to you when you're investing money is the principal. Okay. So that's something I learned this week. Okay. Let's say the bank usually will give you an interest rate before you invest the money. So I'm just going to call that R equals like say 3.5%. That's kind of like a interest rate that some banks give. It kind of depends on the time period, the stock market, all that fun stuff. Okay, now we're going to talk about 2 types of interest. Okay, the first one's kind of easy. It's called simple interest. Okay, and the second type of interest we're going to talk about is called compound interest. Okay, let's start out with simple interest and then we'll start working our way to compound interest. Okay, now simple interest is simple. Okay, basically it gives you the same amount of money every year. Okay, so simple interest, same amount of money gained each year. Okay, so the interest that you make every year is going to be the same. So when you calculate interest, so for example, if I wanted to know how much money I had after 4 years, this is how I would go about it. Okay, I would take my principal because, well, that's what I need, 850. Okay, I'm going to multiply it by the rate that the bank gives me. Okay, but I'm not just going to multiply it by 3.5. I'm gonna write it as a decimal so it multiplies out nicely. What's 3.5 as a decimal? 0.035, perfect. Just divide it by 100, right? And then what I'm gonna do, since I'm interested in after 4 years, I'm gonna multiply that by 4, okay? So I'm taking my principal, I'm gonna multiply the rate, and I'm gonna multiply it by the number of years, okay? When you do that, we get $119, okay? Now, you might look at this number and be like, hey, this doesn't make sense, right? I started out with $850. If I'm investing it, I should be getting more money at the end, right? So, yeah, right? Yeah, so 119 isn't the amount of money in your bank account after this. This is how much that you've increased or the interest. Oh, wow. Okay. There we go. This is the amount of interest or the amount of money that you're increasing by. Okay. So if you wanted to calculate how much money is in your bank account at the end, what you'd have to do to find the total, you'd have to take $850, add on 119, and then you'd know that you had $969 in your bank account after 4 years. Okay. So interest is fun, right? You don't really do any work. You just have your money sit in the bank. And then after 4 years, well, now I have $100 more to work with. Yeah, that's true. The bank fails, then I guess your money's gone. Not very fun. Okay. So just to recap, when you're trying to find interest, well, there's kind of a formula that we use for it. We usually say I equals PR, because P is the principal, R is the rate. And instead of saying like years or something like that, I'm just going to use T to represent the time. Yeah. Okay. So if you ever see a in simple interest formula, that's usually what you're given. Okay. Well, let's go to the next page. Does anyone know what compound interest is? Dagan? Oh. Yeah, let me get Dagan. Let's try that. Yeah.
Well, say you invest $100
Mm-hmm.
means 10% interest over time.
Mm-hmm.
Well, then it's going to gain, or it's going to gain interest on $110 then after.
I think I see where you're going there. That's good, Alex.
The interest rate is like all of what you just.
That's good. That is good. Is that what you're gonna say? Yeah, it's like instead of like just calculating the interest after 4 years, it will actually calculate the interest like daily or yearly or monthly, right? And actually, like after a year, for example, if it's compounded every year, okay, now your next, well, after the next year, your interest is now calculated based on the past year. And then the year after that, your interest is calculated off the past year before that. And then yeah, so it becomes exponential and you actually get more interest when you use compound interest. And I think compound interest is used the most. I think like when you're paying off a house, for example, compound interest means you have to pay more. If you have if you're investing money and there's compound interest, that's a good thing, right? I think so, usually. Yeah. Usually like when you buy a house, you'll get like this huge sheet that'll show you the principal like every month. And it's not very fun to look at, but it's not fun to look at.
It's like you have to pay more every month or whatever. Is that like if I don't know exactly how it works.
Yeah, you don't have to pay more each month, but it calculates like how much you end up paying after 10 years and then it like splits it evenly, but you're paying more. It's just not fun.
So it's not like basically like let's say this completely hypothetical. Pay $100 the first month. It wouldn't be like you pay 110 the next month.
Yeah, usually they like kind of even it out. Yeah, so at least you're not dying at the end.
It's like you're not at least you're not the bills will get bigger.
Yeah, that would not be fun.
Initial price.
Yes. Okay. So this is how I would calculate compound interest for the last example, okay? You have to take it year by year. If you're getting like yearly interest payments, then you have to do it year by year. So let's just try to calculate after year one, okay? So after year one, the interest payment is going to be kind of the same thing that you do for simple interest, but you're just doing 1 year of the whole process. So you're going to take 850, which is your principal, right? You're going to multiply it by the rate 0.035. And this time, what's the number of years? Just one, right? Because it's 1 year, right? So if I go ahead and do that, we actually get 29.75 as our interest, right? But this isn't the amount in my bank account right now. The total is taking my principal, 850, adding on my interest, and now my new payment is 879.75. Okay. So this is the amount in my bank account after 1 year. Okay. Now, what's fun about compound interest is now this is the new principal. Okay. So now the principal that's used to calculate the next interest payment is going to be this new payment, which is more than the last payment. Okay. And that's good for you if you're investing money because now you're multiplying that rate by a higher number. Okay. Okay. Let's do after the second year, after year two. Okay, well, what we're gonna do is we're gonna take our new principal, 879.75. Okay, we're gonna multiply the rate 0.035. What's the time? How many years am I doing? Just one, right? Because now we're just calculating the interest gain from the end of year one to the end of year two, which is still 1 year. Okay, so this becomes, well, I wish I calculated this, but I didn't. Okay, if I were to find my total, okay, I'm going to piece everything together. I'm going to take my new principal, 879.75, and I'm going to tack on everything that I calculated here. So 879.75, 0.035. Oh my goodness, cannot write today.
That's,
Okay.
the interest after year two is $30.79.
Good. And then what I did here is I just kind of calculated how much is in our bank account without doing the interest first. So I just tack this onto my new principal. So I have this.
I'm hoping there's more efficient way.
Yeah, I think we're starting to see that this is getting very tiresome, right? I mean, it's not too bad of a calculation, but if we're we're about to get to year four, right? And year four is going to take a really long time. Let's see if we can simplify this into something. Well, maybe we can get a formula for it or something like that. Okay. Now let's just focus on our total here. I have 879.75 plus 879.75 times all this stuff. What's in common? Oh my goodness. Oh no, it's still there. Okay. What do these two terms have in common?
879.
Yeah, that.
Perfect. Well, if they both have something in common, why don't we factor it out? Okay. And I know it's kind of weird factoring something out that is like a number, but we can still do that. Okay. I have 879.75. Okay. What happens if I take 879.75 and I take away, well, and I factor out 879.75? Just one, right? Because I factored it out. Let's do it here. I have 879.75 times 0.035 times 1. If I factor out the 879.75, what's left? Yeah, the 0.035.
The one also goes away.
Yeah, the one, I mean, we don't have to worry about that yet.
So
Okay.
One person of one.
Yes. So what we have here is this is the principal, right? Okay. This one here is also kind of representing the principal, right? We're taking the principal and adding on 0.035. So this is still the principal. We just factored it out. Okay. And then this is the rate. Okay. Now, if you want to multiply this all together, I actually did that. And if you multiply it all out, you should get a total of 910.54. Okay, so it looks like we did increase a little bit from year one. Okay, now I don't think we want to go for the third year. That's going to take a lot of work, right? And if we try to do the fourth year, it's going to be it's going to be the same amount of work, but we're going to have to do it again. And what if I asked for 10 years? Then we'd have to do this whole process 10 times, which is just really crazy, right? Mhm. Yeah, you're getting there. There is a raise to the power. Do you know why we raise it to a power?
Because you're taking compound interest and it's like exponential.
It is exponential, yeah. And guess what? This 1 plus 0.035, that's actually the key to what's going on here. Okay. If we wanted to do for year three, okay, so year three, okay, we would take the new principal, which is the 910.54, okay. I'd multiply it by 1 plus 0.035, but then I'd have to multiply it by 1.035 again, 1 plus 0.035 to account for the next year. Yeah, so now it'll be squared, right? And year four, we're gonna have to raise it to another power. And year five, we're gonna have to raise it to another power. Yeah, the way I wrote it's kind of weird.
If we're going year four, we would have to add another 1.1 plus whatever to be from the second to fourth.
Yeah. I'd say I wouldn't worry about that just because the formula is just going to look weird
Okay.
by the way it's defined later on anyway. But I think you can kind of see that, okay, if I wanted to do a millionth year or something like that, right? I do 1 plus r, 1 plus r, 1 plus r, all the way to 1 plus r a bunch of times, right? Okay, well, whenever we multiply something by itself a bunch of times, that means that we have an exponent, right? So an easier way to write this is p 1 plus r to some sort of power, right? And I know it's kind of weird the way I set it up this time. I should have thought about it better. But normally we kind of define the question where the number of years is the exponent. Okay, it doesn't really match up in this one, but normally the way the question's worded, t actually ends up being the exponent of this guy. Okay, so this actually is an interest equation, or sorry, a compound interest equation. But this time I'm going to say that a is equal to p times 1 plus r to the t power. Okay, so this is huh? Yeah, that's a good question, right? What is a, right? This is compound interest. Okay, let me write the simple interest formula right below it. Simple interest. Remember, simple interest was I equals P R T. Okay, so you're probably wondering, why is this one I and why is this one A, right? Well, remember the PRT, that was an interest formula. That didn't tell us the amount in our bank account. We had to calculate this and then add it, right? This, yeah, amount, right? This formula isn't the interest formula. This actually does it all in one step, right? This doesn't tell me what I need to add to my principal. It tells me how much is in my bank account, okay? So A here kind of just stands for the amount in your bank account. I here represents the interest, okay? Actually, in this class, we kind of go a little bit further. So we actually don't even ask about simple interest. I'm not going to ask you that on the test. But for compound interest, just know that the A here represents the amount in your bank account, not the interest. Oh, you're good. Okay. So we're going to take this a step further. This isn't actually the formula you have to know for this class, okay? If we flip to the next page, I need to talk about one other thing that kind of messes stuff up, okay? Now, in business, there's this thing called a compounding period, okay? And what that means is basically, well, you don't have to calculate interest once a year, right? For example, most house loans, your interest is calculated every month, okay? And the amount of times that you calculate the interest and figure out your new principal every year, that's the amount of compounding, well, periods you have, I guess. I don't know. Basically, if you compound annually, it means that you're compounding one time a year, right? If you compound monthly, you're doing it 12 times a year. And if you do it daily, it's 365 per year, okay? We have this symbol N here that represents how many times a year that you compound the interest, okay? Now, don't get N confused with T, okay? T is the number of years, okay? In this class, yeah. N is the number of times per year.
Oh, okay.
Yeah. Okay. Now, one other thing that we'll talk about is this idea of compounding continuously. Some banks don't compound annually, daily, anything like that. They'll actually compound continuously, which means like it's just constantly being compounded. Okay. There's no like set day that they're going to compound your interest. It's just constantly doing it. And in that case, we're going to do something with the letter E. Okay. So if we're compounding at very specific times per year, annually, quarterly, monthly, we're going to use a very specific formula with N. If it compounds continuously, this letter E comes along somewhere.
I don't understand what this continues.
Yeah.
There should be a time period where
It actually doesn't. So sometimes it's just like, it's just kind of there and they don't really compound it at all. It's just kind of continuously going on. And then like, for example, if you take a loan out for 4 years, it's just gonna be like, oh, well, we don't actually compound it. It's just compounding continuously. And then at the end of the 4 years, you pay how much it calculates. Yeah.
I just don't know how they exactly anything without actually doing it on even on a irregular time basis. Like, you have to be it's not like every second obviously. So
Yeah, it's kind of like, I
like-
guess like your speed, like when you're like driving your car, right? It's not calculating your speed every 2 seconds. Your speed's changing continuously, right? So that's kind of how it's doing it.
So it's kind of like the rate of the interest kind of changes.
Yeah.
Fluctuates. Is that what it's kind of saying?
Yeah, right. So it's just kind of using this way of like, oh, okay, like we're actually not going to give you a bunch of statements. We're just going to kind of calculate what it is at the end with this continuous compounding
Okay.
method. And then that's how much you pay, or that's how much they pay you.
Like a scam, but okay.
It does seem like a scam, but
Just like you can just say, oh, they compound by a cent.
yeah, and it is actually most commonly used.
Of course it is.
Yes. Yes. Okay, so let's say that we're investing P dollars, so that's the principal, right? The annual interest rate is R, T years, and then N is the amount of times that you compound, okay? Up top, I have the simple interest formula. I actually don't need you to know that. It's kind of just like a building block to this one, okay? But we do have some formulas for, well, the amount in our bank account after a certain amount of time, okay? The first formula talks about whenever you compound daily, monthly, quarterly, or yearly, okay? So whenever you have a letter for N, okay, that's when you're going to use this formula. And if you notice, if you look at the back formula that we just wrote down, it's a little bit different because now we have to take into account how many times that we're compounding the interest. So this formula was when we compounded yearly. This formula is just like how many times we compound, okay? So basically, since we are raising it to the T power, which is how many times that we calculate the interest, well, we're not just calculating it every year, we're calculating it a number of times per year. So that's why NT is at the top, okay? But if we do that all the time, that actually affects the rate kind of because, well, if we're doing it multiple times a year, you have to account for that you're doing it, well, like 4 times or 10 times or 12 times a year. So we also have to take the rate and divide it by N, okay? So this is the formula for the amount of time, or sorry, the amount of money in your bank account after a certain amount of years if you're compounding quarterly, monthly, yearly. You do have to memorize this formula. But if you have your note card, you just write it down, right? Okay. Now, let's say that we're doing continuous compounding. When we're compounding continuously, we don't have a value for N, right? Because N is like 1 if we compound yearly. It's 365 if we do daily. There actually isn't a letter for N or a number for N if we compound continuously, okay? In this case, you'll learn about how this actually shows up if you go to calculus, okay? But just believe me for now, this is where the E comes around, okay? And we have this formula that you also have to memorize, okay? If you ever heard of the PERT formula, this is the PERT formula, okay? I think this is like most commonly used in like business and interest and stuff like that. But a lot of people do compound like daily and quarterly and stuff. So this formula does exist too, okay? So 2 formulas you have to know for this class. What I would do is just write it on your note card so you have it. And right below, if you ever forget what any of the symbols mean, well, I have them right down for you. Okay. I think honestly, this is just easiest if we do an example. I think it'll make so much more sense when we do the example, and you'll see how easy these problems get. So let's just go ahead and do example 5. Okay. So we got through the hard part of the class. The examples are actually way easier than a lot of the other stuff that we do. Okay. So let's suppose we have $5,000, right? So that is our principal, P, right? And the bank invests or pays 6.5% per year, which is pretty good, with a bunch of different compounding options, okay? So let's just say we want to invest for 10 years, okay? And I want to know, like, which option is the best for me, right? Okay. Let's see. Maybe continuously, we'll see.
Daily, well,
Yeah, it's kind of like, which
actually,
one?
with the rate, yeah, we're gonna look.
Yeah, we're gonna have to see which one is better. Okay. So if we compound annually, well, now we have we're not compounding continuously. So we're going to use this formula here, the P plus R over N to the NT. Let me write that out so I don't forget it. P 1 plus R over N to the NT. Okay. Whenever I have a formula with a bunch of different symbols in it, I always like to just go on the side, write down my symbols and write what numbers they are so that when I plug in, it's just easier for me. If I don't do this, I end up making a mistake and it's not fun. Okay. So I think we established that P is 5,000. I know that the rate is 6.5. What should R be?
Well, sorry, 0.0.
6.5. Yeah. Yeah. So the rate is always going to be a decimal. If you use like the percentage, it's just going to mess things up.
That's over like 6%.
Yeah, you're going to get like a really high number. Hopefully the bank makes that mistake when they give your interest. Okay, we have N. If we're compounding annually, what's N? 1, right? Because we're doing it 1 time a year. Okay. And then what's T? 10, right? The number of years that you do it for. Okay. Once you have this written out, this question is so easy. You just plug in, right? So P is 5,000. Okay. 1 plus 0.065 over 1 to the 1 times 10 power. Okay. So literally all you have to do is figure out what this number is. Now, I like to take this step by step, okay? Personally, I like to go in the parentheses first, write down that number, and then raise it to the power. So I think I can do this in my head. 1 plus 0.065 over 1, is it going to be 1.065? Do we agree on that?
Yeah.
Yeah, okay. And 1 times 10, that's easy. That's just 10, okay? Now, if you have a nice graphing calculator, this is really easy. You just plug in your calculator as it looks, and then it gives you the answer. If you have like a bad calculator like I do, or if you're using your phone calculator, let me just show you what you type in, okay? We'd have 1.065, right? And if you want to take it to the 10th power, you're going to have to use that X to the Y symbol there that I just selected. Then you're going to type 10, which is here, okay? Hit enter, and then it's going to give you what you get out of that. Okay, now I'm going to skip steps here. I'm going to go ahead and just multiply by 5,000 now, because that would be the next thing to do, times 5,000, and it gives us 9,385.69. All right, so this 69, yeah. All right, and we don't have to do anything with this number because, well, we don't, this isn't an interest payment. This is like the amount left in our bank account. So this is literally the final answer. Okay. So, I mean, these problems seem kind of hard at first, but once you like write down what each of the numbers are and you know the formula, you just plug into the formula and you get the number, right? Okay. Let's think about compounding quarterly. Okay. So, yep, literally what I was going to say, right? It's everything is the same except now N is 4. Right? The only difference between quarterly and annually is N, right? I know that A is P plus 1 plus 1 R over N to the NT. Oh my goodness, power. So this is 5,000 times 1 plus 0.065 over 4 to the 4 times 10 power. Whew, okay. So let's go ahead and figure out what these are. If you're using a bad calculator like I am, I would go in my calculator, do the 0.065 divided by 4 first, add 1 to it, and then write that down. Okay, so we have, gosh, 5,000 times 1.0163, and 4 times 10 is 40. Okay, so that goes in the exponent.
Wait,
Is that what you got?
no. I did 0.6, in my, I read it 0.065 divided by 4.
Mm-hmm.
That turns it over 800, which comes to 0.01625.
Did you add it to 1?
And I added 1 to it, and it's 1.10. Isn't it just, if you just add 1 to that, if you add 1 to 0.01625, it's just 1.0.
Yeah, that's what I have. I just rounded it differently. I put the 3. Yeah.
Okay.
Yeah. Oh, no, you're fine. Okay. And actually, your number that you get at the end does
Oh, yeah,
depend on how you
said
round.
75 is a 3.
Yeah.
Okay, I'm
Now-
sorry, I thought.
No, you're
Like,
now, since we are dealing with money, I don't really care how much you round as long as it's like 2 decimal places, right?
at the end
Because
of it,
because-
if the final answer has 2 decimals, that's what you want.
yeah, like
Otherwise,
yeah. Yeah, and I'm not gonna like be super hard on rounding at all.
I'm gonna show you work.
Yeah, if you're-
That's-
Honestly, yeah, even at this point, this is fine. Okay, let's go ahead and do this. We're gonna raise it to the 40th power. Okay, and then I'm gonna multiply it by 5,000, and it looks like we get 9,527.79 as our final answer. All right.
Mine is wrong. So I
Hmm.
got a very big negative number.
Oh,
1.3, et cetera, to the 10 times negative 68.
well, I'll go check that out. Why don't we check that after the quiz? I can see what you're typing in.
I just raised.
Yeah,
Oh,
why don't
I'm
we?
sorry, I know I did wrong. I forgot to add 1 to the front of the desk.
Yes. Okay, so if we compare what happens on this question compared to last one, it looks like compounding more gives us a little bit more money too, which is interesting to see. All right,